चलो अपना कान उठाओ।
चल एक ही ट्रेन है सर उठा लो।
जा
पहले सुन ले सर। हाँ कौन मजा आई कौन चढ़ो सारे
बीजेपी सारे सेट से ले बाबे
पीटीआई वाली ये पीटीआई नहीं पता नहीं क्यों। हाँ इंडिया में और देखिए और बाबा देखिए और चूल्हा देखिए देखिए देखिए
ये जो तू
एक और झूला ले चलो 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 चलो
वो भी सही है भाई ये क्या रहा है
इधर देख इधर देख
क्या बात है
ये आपका
ये दो भी कौन सा ये
क्या कह रही है वो मेरा
आदमी कह रही है थोड़ी देर तक यार इसमें बर्फ तो नहीं
आपके बर्फ है कोई बर्फ है
यार बर्फ हटवानी थी
आ रहे हैं बर्फ
आपको तो दे जाओ बर्फ पेंगला पेंगला
क्या बोल रहा है भाई
यार कोई नहीं चौधरी ऐसे ही आएगी आपको पिंगला पांडा देखा है आपने
वो रियल में देखा
सच यार यहाँ एक्वेरियम है चाइना एनजी में तो किस साइड पे बनाऊं
ये ब्लू ब्लू नहीं ब्लू साइड पे इस साइड पे जिस ब्लू में आ जिस टाइम
पर्पल माउंटेन में साइड पे लिखा है नैनिंग अंडर वाटर वर्ल्ड पर किया
ये पेपर डाल रहे हैं
हाँ ये तो क्या रहा है भाई जी भाई इंडस्ट्री फील करिए भाई जिला वाला इंसिडेंट
चेंज करा दिया हाँ सिर्फ एक और निकाल हाँ नहीं नहीं वो नया दिया वो इस कैंटीन में वो हुआ था न्यू ईयर का इस कैंटीन इधर हुआ था कहाँ पे
चार दो लोग थे
कौन ये केएफसी वाले
बर्गर वाले
क्या हुआ था डिस्ट्रीब्यूशन
आप नहीं थे आप
नहीं था
जी बिल्कुल आप नहीं थे न्यू ईयर फेस्टिवल ये कौन बर्गर
मेरे का ये सिंगल है
बर्गर
क्या हो गया बच्चे आ गए तुम्हारे पास
मेरा यही था
I think we can start. Last time we discussed about Panda. We will continue how to load the data and we will go for the plotting today. Because that's the most interesting part. We started it. From today onwards, we will discuss about the plotting also. So just load up the Jupyter Lab environment in your PC and activate. You know about these steps.
It's a piece of feedback.
Yeah, now you know how to open your working lab, you know.
好不好吃？好吃，好不好吃？好不好吃？好吃，好吃。这个吃的呢？
Just open up the last time we discussed about this document.
टेस्ट कैसा है?
This notebook and we discuss about these things. We had also some exercises and we know about like data series and data frames. Do I need to go like a summary or something with this one? We can start fresh from today's because last time we discussed about this one. We had a practical exercise.
Next time there are
Yeah, this one. If you have like observation, you need to do a correction or something, how you can do the correction for the observation data and how you can add some new fields into the existing data frame. Today we will discuss how to read the data like from a text file or a CSV file. Do I need to go ahead with these things because you need to know about some key concepts here. In Panda, we have data series and data frames. Two concepts we need to know about like series and the data frame. Data frame is the combination of multiple series. You can like know it as you can think it as a table. In Excel, it's just like a table. So here we load the Panda and import the Panda into our environment, and then we created this simple series called temperature, and we can see the index and then the actual values. So then we go ahead and created separate indices from this command. Like instead of indices, now we have stations as our index and their corresponding temperature values. So we discuss about these ones and how you can filter the data, and also we discuss some major things like data frames, how you can create a data frame. Previously created a data series. With the help of tuples, we can create a data series, a simple data series. So then how you can access different rows, different columns in the data frame. We need to know about these things. So iLoc, we use iLoc to access a specific location information. Like if you need to access a cell, we can use iLoc. In the iLoc, if you specify the coordinate of that exact variable, we can get the output as the actual value of that cell. Otherwise, we can specify the entire row or entire column to extract that specific column. Today, let's discuss about the loading data into your Panda data frame. So it's also safe. Whenever first thing you need to do is you need to import Panda as PD. This is the first command. Whenever you start coding, you need to import Panda into your environment. So we imported Panda as PD. So if I turn on this variable, you can see PD is a module. It's loaded. In the data section, you can see PD is loaded. So now from PD, we have a function called Panda. In Pandas, we have a function called read CSV. So if you have to read some CSV data or anything, you can use this read CSV command. If you put your cursor within these two brackets and if you hit shift tab in your keyboard, you can see the doctrine of that specific command. So here you can see what are the arguments that you can pass with this read CSV commands. So here we are going to read the txt file. So if you go into a parent directory, this file should be there. So if you open up the text file, you will see. Let me open up the text file. So my file is in desktop. So here I will go into this one, and inside Pandas, I have this txt file. So we are going to read this txt file and import it, load it as a data frame in our Jupyter Notebook environment. So here you can see we have several station data and the time, and also we have temperature, then the dew points and mean sea level pressure. So now we are going to read this entire data. So you can see we have how many lines we have. You can see we have multiple lines and we have some missing data. So here the missing data is marked as capital D. Sometimes you can have like NA or any other character like a dash line or something. So now we are going to read this data. So how we can read this one? So here you need to keep in your mind, here my data file is also like aligned in the same folder with my source code. So I don't need to specify the entire path because the both are in the same directory. Now when you need to read the file, then you have to call like from Pandas, load this function read CSV, and then within brackets you need to specify your file name. Here if I expand this one, you can see my file name, January 17 CO2 A SOS TXT. So this one is like observation dataset obtained from NOAA website. So now we have to assign, okay, if it is a text document, what is the separator? Even you sometimes you have like tab separated, tab delimited, and comma delimited. Those guys. Like if you open Excel, let me open Excel. So just imagine you have any sort of data, and now when you going to save this one in your PC, you can see when you're trying to save this one, here you have multiple options. You can save your CSV, the Excel file. Here you will see, even in the CSV we have this option here, you focus, we have comma delimited. So you can see each and every individual value is separated by a comma. And we have another function named like tab delimited. You also can see there should be another thing called tab delimiter. So here you can see the txt. The format will be txt and it's delimited by a tab. So each and every individual cell is separated with a tab. So right now in this text document, here.
Yeah, I've been using that one. दिमाग में कुछ आया
बहुत लगाओ
This one UTF-8 mean like if you have like except English, if you have the data in your own language, you have to save using UTF-8 or something. It's a character. Just imagine you have some data in language or Chinese characters or something. Then you have to save your data with UTF-8. Otherwise, if you save this one as like CSV command immediately, the below one, when you try to open that dataset, you might see like the characters are not visible correctly. If especially this one is going to happen like if it is not in English. If any other language like or the Chinese symbols, you have Chinese characters, you have to save it in UTF-8 format. Otherwise, those things are not going to save in the file. It's already there, but it's not recognized. So in here, if I open this one, you can see each and every individual cell is delimited by a tab. So it's not a comma. So after that, in our code, we have to specify, okay, load this file, then comma this file. each and every individual cell is separated by tab. That's why we put like this slash in here. That's why we put slash t. Now if I execute this command, in the variable panel you can see df data frame is loaded. So here this one is like my variable name, actually the data frame name. Short form data frame. Instead of df you can use any name. But you need to keep in your mind, you call this thing as your, this is your data frame name. Then equal.
I don't like it.
दो जो उसमें जे इसके साथ मिक्स कर दी है बाद में कहूँगा मेरी भी थी
Yeah.
मेरे हैं मेरा ऐसा
Let me run this one also so you can clearly see. So let me
बाजू बाजू कौन कॉल कर रहा है
this part. So if I remove this part,
बाजू कौन है
you can see the data is already read, but we are talking about data frame.
क्यों मैंने
Now
कहा
if I need to view the df, I can type like df. Here you can see how it read. There is no any separation between columns. You can see there is no any separation between columns. I only have like, this is the index column and this is the data column. The data is not separated into different axes. You can see in here the data is organized. Like stations are in a separate column, then the time is in a separate column, temperature is in a separate column, these values are in separate columns. We can load the data like this, but when we are trying to do the analyze, it will confuse. You can see the difference. Now if I load the data frame, just let me move this one into the below and let me load the data set now. If I load the data set now, you can see I have separate column for each and every individual data file. So that's why you need to specify the separator in here. If you use comma separator, then you have to delimit the, instead of t, you have to specify, okay, this one is comma delimiter. So then this one will automatically know, okay, these are the different columns and these are the respective values for each and every individual column. So now also, even though I see this one in my table, if I print df info, you can see the information about your data frame. This is a short command that you can use. If you type your data frame name .info, it will give you the each and every individual details about your columns. So here I have how many columns: station valid, then TM temperature, then the dew point, and then mean sea level pressure. And I also can see the corresponding data type for each and every individual column. So the stations are in the object type and the time is in object type and the temperature is also in object type and the dew point pressure is also in object type. Now here I have a small issue because if I talk about time, instead of object, this should be like date and time. So how I can load date and time in the exact format? So to do that, when you like reading your CSV, you need to specify, okay, this is my file and it's separated by tab. And then you need to specify this one. Here you cannot change, like you cannot like use capitals or simple. You need to use the exact word like phrase dates. So now you are going to specify, okay, this axis contains date value. So in my original file, I can see valid is represented by the data. That column means the date and time. The specific date and time, whether like this data is recorded. So now I need to specify, okay, this is the column, the valid. That means this column means should be in the date and time format. So if I execute this one, now if I view the heads, the table stays the same. You cannot clearly see the difference. It look like same, but if I view the info, like if I view df info, you can see now the valid. Here you can see clearly now this one is converted into date and time. Now Panda knows this specific column is in date and time format. Now you can deal like monthly, seasonally, or those kind of annual averages you can take, because now it's no, okay, these values are in date and time format. But previously, if you're going to do something with like this one, it's going to confuse. Even though we think, okay, this one is in date and time format, why this command is not working? It's because Panda doesn't identify it as a date and time. When you need to keep in your mind like, okay, my data set is read. Okay, what's these issues? Even though you loaded your data, you need to double check whether these columns are in the correct format. Now, okay, this one is also okay. I can see these things. Now I know my null values are represented by M, but Panda data frame doesn't know this capital M means null value. So when I load in the data, I also need to highlight, okay, whenever you see capital M in my data set, it represents a null value or missing value. So when you assign in this one, you have to use this NA values. So if I view the doctrine, you will see in the doctrine, we have this one. So you can specify NA values. Always check this doctrine. In the doctrine, it include all the necessary like things that like arguments that you can pass inside into this specific function. Even though I am using like only 1, 2, 3 arguments, if you have multiple arguments, you can pass this each and every individual argument inside into your read CSV function. So if I execute it like this and view the data frame and df info, now you can see these values are converted into float. Previously we had like object, and also you can see when you view the data set, instead of M, now we have NA. That means now Panda knows, okay, these values are missing. When we going to calculate mean or something, it knows I need to exclude these values from the calculation. Otherwise, if you use like you load the data and you didn't specify, okay, these are my missing values, and Panda doesn't know, it will recognize this one as like sometimes you instead of this capital M, sometimes you mark it as like -99 or something. So if it is a textual like that kind of value, it will include. Like just imagine instead of capital M, you have -99.99 as missing values. Here you have assigned like instead of capital M, you have to type -999.99 is my missing value. So it will understand, okay, these are the missing values in your data. Okay, now we can see, even though we loaded the data, this station, like this row doesn't have any information. So it's useless. If you use this kind of rows for our calculation, it's completely useless. So now we need to do the filtration part. How we can remove these rows? Like even the temperature is there, temperature value is not there for that specific station, that specific time frame. And even the dew point temperature is also not there. And the mean sea level pressure is also not there. How we can remove those values? To remove those values, we can view the columns by using this one. First, we will try to rename these columns. Right now, we have like station valid. Instead of valid, this one should be like date and time. And then instead of TMPC, we should know like simply we can type like temperature. How we can rename these things? We learned this one before. How we can rename the index? The heading of the this one we can rename like this. If we specify df columns, now it knows, because if I print df columns, it will give me these values. So if I specify df columns equal, then I have to type the values for each and every individual column. So the first one here I have how many columns? 1, 2, 3, 4, 5. So here also there should be like 5 columns when you are trying to rename. So the first column will be station, the second column will be time, and the third column will be temperature, and the fourth column will be dew point, and the last column will be pressure. So if I execute this one and view the DH head, DF data frame head, so it will print the latest 5 lines in your data set. Now you can see it's renamed. Previously we had like something called station valid, TMPC, DWPC, and MSLP. Now we have stations, time, temperature, dew point, and pressure. It's okay, you can use the same exact format, but you need to keep in your mind, you cannot use like, if you are dealing with the time, you have to type value, not date and time, because your column name is value. That's why we rename this one. Then we have to deal with the missing data. Okay, here you see we have the first row, second row, third row. We don't have any values. For those stations at that time, we don't have any values recorded. So how we can remove those data? Because if we included this one for the calculation, even though there's no data, it's going to use some amount of RAM in your PC. So before you include these files, you need to filter your data, like clean your data. Now we are going to clean the data. So how we can remove these missing lines? So in Python, we have, in Panda, we have, because here the length command means how many lines you have in your Panda data frame. So here you can see how many records you have. So here how many records we have? Around like, yeah, around 1 lakh we have. 169,000 lines we have. That means the entire data set. So now we are going to filter our data. So we can filter like df drop NA. Drop NA is a default command that we can use. Let me view the doctrine so you will understand. So before I print this command, I can type df dot drop NA. So if I view the doctrine, it's giving me like this: drop NA, remove missing values. Always check the doctrine. If you have, if you encountered an error or something, you need to know about more about this function. I say like several methods. One is you can type comma at the end. Other one is like you can go file and new launcher, and from there you can load contextual help. The second method. The other method is, instead of typing this comma, you can go into the function directly, and within these two brackets you can type shift and tab. It will also load the doctrine for that specific function. So you have three methods. You can choose either of these. So this one is going to, this remove NA function is also included in Panda. So it will remove the values, the missing values. In here we have several arguments that you can pass. What is the axis that you are going to remove? Either it's a column or a row. If the values are missing in the entire column, you can remove those all the columns. And you have to specify the axis. And then you have, okay, how? Any of all or all. You can type that one also. Here I'm going to use this function. Okay, axis is rows. That means I'm going to remove all the rows where missing values, like values are missing. If then I have to specify, okay, how? That means all. All mean if here I mentioned like subset. Just select temperature, dew point, and pressure column. Just focus on these columns. If all the values are missing in these, just take a one row and check for this temperature, dew point, and pressure. And if all the values are missing, then remove that row. That's this command mean. Like first df drop, then axis. Okay, remove these rows where temperature, dew point, pressure is missing. How mean the method? And within two brackets, you need to specify remove all. That means it will check whether temperature is there, dew point is there, and pressure is there. And if all the values are missing, it will remove that row. But if temperature value is there and the dew point is missing, and also pressure value is also missing, but temperature is there, so will this command remove that row or it will keep it? It will keep, because here we are checking like all. If all the values are missing, that row is going to omit. Otherwise, it is going to keep that row. If I execute this one and view the df length, now you can see. Now I only have 72,000 rows. Just now you can see it's reduced to half. Just imagine if you use that entire data set for the calculation, it will take some lot of space in your PC and even your memory. Sometimes it will give you some errors. Now even you can view your df head. Now you can see the first three commands are removed. from here, because previously we can see these all the values are missing. Now these 3 rows are removed. But now we have another problem, like, okay, here we will discuss about that thing later. So now you have a small exercise. Okay, now previously we discussed if all the values like temperature, dew point and pressure is missing, remove this line. Now you have a small task. Okay, if pressure value is missing, just remove the entire value. Like for sometimes for your calculation, you need, like, just imagine you have for this station, you need to have temperature, dew point and pressure. Even one value is missing, you need to remove that row. Now you are going to select only the values, like if temperature, dew point, pressure, and all the values are there, just keep that row. If one value is missing, just remove the entire row. How you can achieve that one? The same command. Here, this is the command that you have to use. You have to change only one location in here, because we are focusing on the rows and all of these values. Instead of all, if you have common sense, you know the word. If all, then the other command is, if any of these values are missing, just remove this line. So here it will be any. You can try. Just instead of typing df, you just you need to type df2. Here I also give you a small hint, like you can type df2, because if you type df, that means you're going to override that previous data frame. Just type like df2 and you can use the same exact command, and you can see. Let me copy this one and paste it in here. I have already here. So if I execute this one, now you can see. Previously in here we have, for the third row, we have none value in pressure. But if I type like, okay, df2 drop NA, how? Any. If any of the values are missing in the data frame, just remove that row. So here you can see it's left with only the rows that which contain like all the values for temperature, dew point and pressure. So it depends with your work. Sometimes you might need like all the values, or sometimes you might only need 2 or 3. It depends on your analyze. So you can use these 2 methods. So next is like, okay, now you can see our index is like completely scrambled. Like, because the first index is removed, second index is removed. Here our first index is 10.4.22. We are going to focus on this one. Here our, if I, let me print before I reset this command, if I view the data frame 1, you can see the first index is 3. But now the old value is already there. The index value is already there. Even though we remove the rows, indexes are not reset. Now we need to reset the indexes. So how we can reset the index? In the Panda, we have an inbuilt command, reset index. And drop true mean is going to drop all the previous indexes and assign new index. So if I execute this one and view the data frame, now you can see yeah, I just reset this one. So if I type like df equal df reset, now it's going to reassign back into your data frame. Now you can see the indexes are reset. Now, okay, there are small things like how you can manipulate inbuilt functions in the Panda. We have like inbuilt functions.
If data are missing, I need to remove the entire column instead of rows. How can I make that?
If the entire column is missing.
Yeah. For example, data like pressure. See that. So instead of removing the rows, the column.
But here I cannot see the entire data set. You can see the first things only, because here I am going to use like, if any of these data is okay, just keep the value. Here, even though you see like, okay, the first values are not there for the pressure, maybe like the 5th or the 10th value for the pressure, that for that specific record, the pressure value is there. because you cannot see the entire data set, because if you see the entire data set here, you can see for this, the last row, we have the value for pressure. Because here also we don't know from 10 to this value, you don't know whether the pressure value is there or not. If you have such kind of thing, you have to mention like, okay, from here, instead of rows, you have to specify, okay, columns. Here you need to specify columns. You don't need to type like all. You can type, if you type all, it will select like, okay, check for these columns, whether the values are there or not. Yeah. Then if the value is not there, all the 3 columns will be removed. If you type like any, then it will check for each and every individual column whether any of column has like missing values. If there are missing values, it's going to remove the entire column. It will check the column. Instead of row, it will check the entire column. If you type like all, that means if all the values in that column is empty, that column is going to be removed. But if you type any, if any of the value in that column is empty, even though some like rows has the values, it's going to remove the complete, like that column complete. Otherwise, you know about this one, instead of typing like drop, you can subset. We discussed about this on previous, like how you can subset the data frame, like how you can select only these 2 columns, omitting 1 column. The previous section we discussed how you can select the specific range of columns and all the rows. You can type like df 2 equal, then your selected column. So it will select that specific data only. So this is like if you have the values in the rows, if the values are in the column, it's okay. If you have something, you can use the same exact command. The command will be like same, the same exact command, where is it? Drop in this same exact command. So here if I shift tab, you can see axis. Here you have to mention the axis. If I type 0, it will be rows. If I type 1, it will be columns. Or you can type like either rows or columns. It's also fine. And then we have how, any or all, 2 commands, either any or all. Here also you can go into the bottom and you can see they provide some examples. So here they created like data frame. So here if you need to drop, so here you can see axis column, that means going to remove all the columns. If you type like axis columns, now okay, here we have this data frame. Now remove drop in axis columns. Now it's going to remove all the columns. It will only remains the name, because in the name column you can see all the values are there, but in the toys we have none, and also for the bone we have none values. That's why these 2 columns are like removed from the data set. Always if you need to know something, either you can search in the web or you can view the doctrine. But my suggestion is just view the doctrine. You will see some examples over there. Okay, the next thing is
So if I need to take the user service, for example, I don't know which service I'm picking that I need to remove those cells. It's not the entire or it's not the entire. I just need to select those cells with missing patterns. Remove them.
for that thing, if the data is yours, if you obtain the data from somewhere else, they will specifically mention like these are the values we use to represent the missing values. If you download data from somewhere else, like station data or somewhere in the site, they mention. Here at the beginning, we specify like, this is the file that we are going to load. Here they specify like the missing values as capital M. Here they specify like the missing values as capital M. When we load the data, we specifically call this one, NA values. That means none values are represented by capital M. So then it will know, because this is the command that we are going to load the data. So we use the read CSV function, and then we type our actual file name, then the separator. This is the text file and the separated with tab. Here you can see this file, the delimiter is tab. If you highlight this one, the separator is tab. So it will know that this data is in tab delimited format, and then we need to specify, okay, this column contains the date and time. I think you're missing this part, the reading part. You're not in here. So here when you load, we need to read this one first, and then we can type like pd read CSV, then the file name. Okay, if we execute this one, you can see if I view the data frame after executing this one, if I print the data frame, now you can see this is the data frame look like. I only have the index values, and then here I don't have separate columns. When I load the dataset, if I use this function, you can see the stations and the temperature and these things are not separated. You have a small hint in here. When you load this data like this, you have a small hint. Each individual, like when you try to separate each and every individual cell, you can see there's a small hint over there. You can see the separator in here, -T, -T, and here also you have -T. Here also you have -T. Now you know what you need to use for this specific delimiter function. So then you need to specify, okay, these columns are specified like delimited by, separated by using this /T. So if we use this one, included separator, sep means the separator. If I view the doctrine of this function, you can see we have a argument called separator. That means here you have to specify the specific separator that you are used. If I go into the bottom, here also they provided some examples. Always try to go into the doctrine and see. They provide some examples for you. I think here we don't have. Here we don't have. Here we don't have some informations, but here you can see all the arguments that we can use inside that function. So now if I type like separator, okay, these columns are separated by /T. So separator equals /T. Now if I execute this one and view the data frame, now I can see I have columns. You can see the difference with the previous one and this comma. Now you have separate columns. Now if I view here also, let me execute this one and type df info, then you will know. Instead of df, I will type df.info. So it will show me all the columns and their data type. So here you can see I only have one column. If I use this command, I only have one column and the data is in object data type. If I execute it like this, the reading part like this, and view the df info, now I can see how I have 5 columns. But I have a small issue in here. I know valid is in date and type format, but it's not recognized in the correct format. So how I can read or load this data? Okay, this column is representing date and type. So when I read the data, I need to assign that one also. To specify, okay, this column is in date and type. you have to use this phrase dash dates argument. It's an inbuilt argument. If I view the shift tab and view the doctrine of this function, you can see it's a inbuilt base date is inbuilt argument. So you cannot change this one. Then you have to specify the column. In your actual data, you have these columns: the station valid, then TMPC, DWPC, and MSLP. So you have to specify, okay, this valid, the name of this column is valid. So that column should represent date and time format. So if I execute this one and view df info, now you can see the second the data type of the second column is changed. Now the data type of second column, that means the valid column is in date and time. Now the Panda data frame knows, okay, this second column has data, but it represents date and time. But if I use this one for the calculation, just imagine I need to get the monthly mean or the annual mean or something. Even when I try to run that command, it will confuse. Even though I see like this one in the valid, it like appearing like the date and time. So here also you can see in the original data file, you can see it's look like this, appearing like a time. For you, it's appearing like a time. But for the Panda, it doesn't know. If you use this one, it doesn't know whether this is a like simple string or in the date time format. That's why we need to specify, okay, this is in date time format. Now it knows about this column. Okay, this valid column contains the information regarding date, not like object or string or floating type data. Now, okay, we loaded the data. Now we need to specify our missing values. Because even though we know, okay, we know from the data file, we know this M represents the missing values. But we using Python, this Panda library for our calculation. Before we go in for the calculation, we need to specify. Okay, if you see something named capital M, this represents a missing value. Here, if I view the doctrine, I have a specific argument. For this one also, I have a specific argument. Here, I have a specific argument called NA values. That means it's representing null values. So NA values are represented by capital N. So now if I execute this one, it knows everything regarding this data. You can see, if I load only the file, what will happen? It doesn't know about different columns inside that file. Then I have to specify, okay, my file is using tab delimiter or the comma delimiter. You have to specify. If you are using tab, you have to specify like /t. Then you have to specify, okay, these columns are containing the date. Then you have to specify, okay, these columns contain the dates, not like typical object or string or floating type data. You have to specify that thing also. After that, you have to specify, okay, these are my missing values. Sometimes these missing values like represent, like when you download the data, sometimes the missing values are represented by like -999.9 or something. You can see something like this. Sometimes when you download the data, you will see something like this. They will mention like, okay, this value represent the missing value. But just imagine if you didn't specify the Panda, you didn't tell to Panda, okay, this value is a null value. And you use this value for the calculation. Just imagine if you go for the mean or something, this value will include it. Because you didn't tell, okay, this value is represented the null value. That's why we specify, okay, NA values are represented by capital N. If we use this one, now you can see, now instead of M, is using capital NaN. That means it knows these values are non-values. If I view the info now you can see, instead of this object type data, this one is already converted into the float values. Now it completely know, okay, these values are floating values, like the numerical values. So now we can deal with the data. This is how we load the data. for our initial analysis. Now we need to remove. The next step we discussed. The next one is like removing these values, because if I view the entire data set, you can see how many lines I have, how many data rows I have in my data set. So here you can see I have around like 169 rows in my data. But when I look my data frame from here, I know I have some rows where it doesn't contain any actual values. It's useless. You can see these 3 rows are useless, because why are I going to deal with these 3 rows? Because there's no any values in there. But if I go for the calculation, it's going to go through each and every individual these rows also. Even though there's no any values, it will calculate like, for the calculation, it should go through each and every individual row. But if I remove those rows, it will be easy for my PC to deal with that data. Now I'm going to remove those missing values. For this specific purpose, I don't need like, okay, now, okay, how we can remove those data. For that thing, we use this dropna command. It's also an inbuilt command in dataframe. So if I type like dir within bracket pd, so it will give me all the functions that comes with Panda. Inside the Panda, all the functions that I can use. In here, you will see dropna also in there. Go to. So here you have to check the dropna also should include in here. So now how you can use this dropna to remove those values. So we know if I view the doctrine using this one, in dropna I can use these 4 arguments like 1, 2, 3, 4, 5, 6. These are all the arguments that you can use with this function. If first thing is I need to assign, okay, check for these rows. Before you drop those specific rows, I need to drop these specific rows. And then you need to mention, okay, how you going to remove those rows. Either one value in that, like one cell value in that entire row is missing, just remove. Or check for all the columns in that row, and if like all the values are missing, then remove this one. Can you elaborate on this one? Can someone elaborate on this function? Like now, okay, subset mean if I have more than, like, just imagine I have temperature, dew point, pressure, and I also have another value in here. But from that entire data frame, just focus on these 3 columns. Just focus on these 3 columns. Now I am telling Panda to focus on these 3 columns and check whether any of these values are missing. Here, that means all of these values are missing in these specific columns. It will check for the first column. So if I print the data frame, before I execute this one, let me print the data frame here. So if I view the data frame, so here you can see in the first column, temperature, dew point, and mean sea level pressure. There's no value for those 3 things. Before I execute this thing, I need to rename my data set, because here you can see my data frame. I have valid TMPC, DPWC, and MSLP. But instead of using this one, I can like rename my columns. How I can rename these columns, like DF columns. You know about this function. We discussed about this one in the previous section. The last session we discussed data frame columns will give you all the columns you have. Like I have stations, valid, then TMPC, DWC, MSLP. Instead of using these default column names, now I am going to rename those columns. How I can rename those columns? I can type like df columns equal, then within 2 box brackets I have to type my column names. Now it will rename all the column names. Now I have station, time, temperature, dew point, and pressure. Okay, now I am going to filter out my data. If I have something like temperature, dew point, and pressure, all the three values are missing, I'm going to remove that. For my calculation, I don't need that. So that's why I'm going to remove those things. Before that, you can see, before removal, you can see how many rows you have. 169,000 approximately. You have around like 170,000 rows. Now I need to remove, if one column has like, if just select this entire row and check for the temperature and then the dew point and the pressure. And if one of these values, like all the values are missing, just remove that row. So that's why I use this command, like dropna axis is rows, method is remove all, and specific focus on these specific columns. So if I execute this one and view the length of my data set, now it's reduced to 70,000. Now you can know, like for the processing, this will be much easy for my PC. Because previously I have had around like 107,000 data, but now I only have 7,000 data, like useful data. So now if I view my data set, you can see I only view the first values in my data, but here my index is not in order. Now I need to reset this index. For that thing, I can use this df reset index command. So now it's going to reset this index. If I print my df.head in here, you can see the index are not in order because I dropped several rows. That's why. Because I asked it to drop several rows from my original dataset. Now it's dropped, but the indexes are not reset. Now I have to reset my index using this command. So if I use like type df.reset, it's an inbuilt command, then drop through, that means it's going to drop the previous index column and reassign the indexes as 0, 1, 2, 3. So now you can see is reordered. Now, okay, how you can view the minimum and the maximum value? Just imagine in the temperature, you have 7,000 rows. How you can check the minimum temperature and the maximum temperature? For that thing, we have inbuilt command. So here you can see print f mean, that mean is going to print in a line. Okay, minimum value is this and maximum value is this. Instead of I can use like this command, like df dot then my variable name. I need to focus on the temperature. Then dot mean. Mean is an inbuilt function. If we type it like this, from the data frame, select temperature, focus on this column and find the minimum. So if I execute this one, it will show me this value. That means this is the minimum value in my data set for the temperature. So the same thing goes like this. If I type like df dot temperature dot max, it will give me the maximum temperature value. So now you know your data is fall within this range. So this one is just to verify, like if I execute this one, it will provide, okay, the minimum value is this and the maximum value is this. This is like a formatting. So these are the two commands that you need to focus. Then the correlation. Just imagine you need to do the correlation. You need to check whether the temperature is correlated with the dew point. Like if the temperature is increasing, dew point is also increasing. That's what we simply the correlation mean, as you know. If the correlation is negative, what does that mean? If temperature is going to increase, dew point is going to decrease. So you have the inbuilt like the statistical functions also. Like if you can check this one, just let me copy this one and type temperature dot and it is not giving me all the values, but you can type CORR. That means it's going to correlate. You can type your variable. That means you are going to correlate temperature. Then you have to specify, okay, you with which column you are going to correlate. Now I am going to correlate this temperature data with dew point. So it will give me the correlation value. So this is the value. It is positively correlated and it's around 0.74. So there are some small functions like this inside Panda also. But for this thing, if you go like advanced calculations for the statistics, we have to discuss about that SkyPy library. So if you go more than like more advanced than this one, we need to focus on SkyPy. So that library is there for the advanced mathematical calculations. So if you go into this website, you will see all the functions you can use. We need to discuss about this library also. So here you can go inside and check. But here we only you can also do a simple correlation. But to do a correlation, you should know that you need to have the same exact rows. If you need to correlate like temperature with dew point, then you need to have same exact number of rows. If this one has like for your data set you have like 20, for this one also you need to have 20 values. Otherwise we cannot correlate. The sample size should be same. Because for these correlations you can use like SPSS also. Then okay, this command used to like we have an inbuilt command group by. Because from the data file, if I view the data file, if I view my data and let me bring the entire data set. So here you can see the station. The same station is repeated several times because the time frame is different. Now just imagine I need to get the mean value of each and every individual station. How I can do that thing? Like I have separate stations. For that same station, okay, what's the mean temperature and what's the dew point temperature and what's the mean pressure? So for that thing, we can use this group by command. In the Panda, we have group by function. So if you type your data frame name dot group by, then you need to specify, okay, group by this is specific column. Then it will go through each and every individual because in stations we have different code names. Now it will go through each and every individual code names and calculate the mean for those specific stations. So if I execute this one, now you can see how many stations I have. Only 4 stations. For that 4 stations, it automatically calculates me the temperature. Okay, for this code name, the station with this code name, the temperature, the mean temperature is around this value. And the dew point is around this one and the pressure. We don't have any values for that station. But for this station, we have pressure value. So you can use this command to get like the group wise mean or something if you are going to deal with this one. Okay, there's a small exercise for you how you can calculate the minimum, maximum, and the standard deviation for this each and every individual station. So now you know you can group by the station and then you can get the mean. Instead of mean, we can use like minimum, maximum also. If I type like mean in here, what will happen? It will show me the minimum value for each and every individual station. If I type like max, it will show me the maximum value for that each and every individual station. So here you can use, and if you need to view the standard deviation, you can type .std. So it will give you the standard deviation of this every individual like station, the temperature. It has this kind of standard deviation with the mean value. So also we have this simple command. If we don't need to get the minimum, maximum, standard deviation separately, we need to view the entire thing. You can type, okay, group by station, then describe the data set. So if I execute this command, you will see it's going to create this line. So now you can see, if I focus on the pressure, I have mean, minimum, 25 percentile, 50 percentile, and then the 75 percentile, and the maximum value and the standard deviation. Now you have the entire description. For the dev points also you have count, number of like values, and the standard deviation, and the maximum value and the minimum value, because here is showing only here is like minimized the last rows and the first rows. So here also, if you need to reset, you can reset this one, because here also the data is not resetted. Now if I type this one like get groups 0, then the head reset index. So you can check, like if you need to get all the values, like if you need to extract, okay, group by the stations, and I need to get this specific data, like entire data of this specific, like this data set. So how you can extract? Then you can type group by station, then get group. That means your station name 0CX. So here, if I need to get this station, I can type okay, group by stations, then get group, then my station ID, and then only the first 5 rows, and reset the index, drop true. I can like omit this one also. If I print this one, you can see it gives me all the records related to that specific X station. So this is how you can manipulate with this data. So the next thing is like rounding up. Okay, now just imagine for the temperature we have, if I view the data frame, let me view the data frame by typing df. So here you can see for the temperature I have point values. I didn't round up this one. Here you can see like minus 0.22. Now if you need to round up those values, how you can round these values? You don't need the decimal point. How you can round up these values? So that thing you can use df, then your variable, then round. So let me execute this command. We remove this part and use this one. So now what will happen? df temperature dot round. What will happen? If I execute this one, you can see it's going to round up all the temperature values. Now, if I need to group by the temperature values, just imagine I'm going to group by the temperature and then get the count. If I execute this one, you will see. So here minus 29.0 is there. Only one station represents this value. So how many stations have this value? Like the temperature, like around 35. I have like around 103 records with my entire records and the dev point. So these are the stations. Like you can do simple calculations like this. So what does this mean? It's going to group by according to the temperature column. Whatever the temperature value you have, it will group according to that temperature data. Previously, we grouped this one according to the station. In here, we group by the stations. Now we group by temperature. So if you group by temperature, you will see, okay, if this temperature is represent, okay, how many times that value is repeated in your data. So you can check. So the average temperature is varying around 35. You can check those things also. So that's how you can deal with Panda, like how you can actually read the data using Panda and how you can do simple calculations with the data. Because previously, I think I don't know whether you forgot these things also. You need to remember these things, how you can do subsetting and how you can view the data shape and access separate values and the separate columns. We discussed about these things. You need to recall. If you forgot these things, you need to recall this one. Okay, I think now you know about the pandas. Let's go for plotting, because now you know about something related to the panda. Now we can go for plotting. So we will go for a simple time series plot. I will send you the document. Let me send you the document for this time series plotting. You need to download that one. We will go for simple plotting now. I have sent a file into the WeChat group. You have to download this one for the time series plot, because since you know about the panda, we can generate plots now. So if you know about something related to the panda, we can go for the plotting. So you have to download this one and place it in your IMSA Buoy folder. So I will send it into the both groups and also to the chat section of this content media. You can download that file and extract it. So after that, you can open this one. After downloading, you can open that file. So this is the file. You have to open this file. Because since you know about the panda, now we can go for a simple time series plots. So you have to load this file. Just load this file. So you can go into your where if you load Yeah, actually, we are really no different. It's it would be snap. It's really when you take on rock the you there. Start the that's so how many people are in this one? Wow, this one we can go so if you have this one here, we will discuss about another thing like how you can obtain the data if that from the directory from the server. Like here, I'm going to use this data set, national Buoy data from NOAA. If you go into this website, you will see we have several buoys allocated by NOAA. Their network environment, you can see we have several buoys located inside the sea, in the sea. Or like if you're dealing with SST or something, you can see. Now we are going to read one from here. We will focus on like, because if you view this data, you can see stations with the recent data and the stations with the historical data only, and we don't have some stations didn't update their data because there might be an issue and they need to be repaired. So here we will focus on a specific station. So we can focus on this station or any station is okay because you have to focus on yellow color station because those are the stations we have recent data. Because here you can see the station ID, and also if you go into the history, you can see what are the data we have with that station. So it will show you all the historical data. Like if you need the historical data, you can download like TXT files. For this one, we are going to access the recent data. We are going to access the recent data. For that thing, we are using this NDBC connector. So here we have a library called Siphon. You can search for this one. We are using Siphon library. So this is a library. If you search for this one, so here we have this library. We are going to use this library. So it's also a library like Panda, X-ray, like that. We have a library called Siphon. If we use this library, we can access this data set because in the example, if you go into the examples, you will see we can access several libraries. If I go into the examples, why it's not loading? So if I go into here, even you can access this NCC dataset also. If you need to access this NCC dataset, you can use this Siphon library. And also if you need to access this data, you can use this Siphon library. It's just a connector where instead of downloading the TXT files, now we are going to directly access the data from the servers. We are not going to download. This is just a connector. Sometimes you might deal with these things like a wget or something. Now we are going to use this Siphon to get the data for this specific station. So first we need to import this one. So this is the library we're going to use. So here you can see if you go into the installation guide and then the examples. Let me go into the examples. So for the from the examples, if you're going to request this data, you have to import this library. So if you need to get some data from this specific station, you have to first you need to import this one. It's just a connector. It's a web connector. So first line mean I'm going to import from Siphon. I'm going to import this simple web service NDBC, and I'm going to import it as NDBC. So now I can type NDBC and then I have to type Buoy data. So I'm going to access that Buoy data. So here, if I go into that specific website, they say, okay, if you need to retrieve the specific station data, you have to import from Siphon simple web service NDBC, import NDBC, and then you have to type okay. Just check the data whether the data is available or not. Equal NDBC from this library. In there we have. I can type like, let me type this one like, because I already imported NDBC, I can type dir within bracket NDBC. Now I can see all the functions that comes with this command. So here you can see I have a function called BOUD data types and the latest observations and the real-time observations. So these are the several functions I can use. For this specific function, I am going to use Buoy data types. Then I need to specify the station in here. So if you go into the station network from here, if you select some station, just imagine if you are focusing on El Niños, La Niña or something, you know about these regions. So I will focus on this station because it has a recent data, or you can focus on any station, but you need to check whether the data is available or not. Now I will focus on this station. So just click here and then you will see the station ID. You need to copy this station ID. If you are focusing on this specific station, you need to copy that specific station ID and place it in here. Now, if I execute this one, what will happen? From my Python like Jupyter notebook, it will send a request to the NOAA original website and try to access this text file. So instead of data types, let me type okay, now it's going to access this specific station data and it will provide you what are the variables you have in that specific station. So I have the data is in the standard meteorological data, and I have the wave summaries, and I have raw spectral wave data and the spectral wave data and several data. So I know I have data for this station. Just imagine if I choose a station with the red color. Just focus on here and I type this station ID. Let me copy this station and type it in here. So if I type it in here and execute this one, you can check whether the data is there or not. So it will take some time because it's going to request the data for you and load that data directly inside your notebook, because the data file is not even in your PC with you. You're going to access the data directly from their web server. That's why it's taking some time. So here you can see I just only received empty bracket. That means I don't have any data for this specific station. Also from the site, they mentioned like if there's like red color indication, that means there's no recent data for that specific station. That's why I ask you to focus on a station with the recent data. So now I will focus on this specific station and I can check. Okay, instead of checking whether the data is there or not, now I know for this station I have data. Okay, how I can get the real-time observation? For that thing I can type NDBC. That means this from this library. If I last time I show you guys, okay, if I type dir NDBC, I know I have this real-time observation function also in there. So if I use real-time observation, I can type shift tab in here. So they mention retrieve the real-time Buoy data from the NDBC website. So then you have to type OK. Then you have to give the station name. From here, you know, if I view the doctrine, I know it's passing name of the OMC. So they didn't provide the example, but you know, you need to pass the name of your station. So if I execute this one, now it will take some time to retrieve the recent data for this specific station. Now I can type like df tail. So here you can see the specific data, like different data that you have with this specific buoy. So you will see, if you focus on the time frame, you can see the time 2024 3. Now we type like df tail, that means the latest, the last records. If we type like df head, it will give you the latest records. Let me type df head. So from here you can see the latest record. The last record is 2024 5 7 and this time frame. So we can access this data, and how many data we have. If I view the tail, you can see up to this we have 6,472 rows we have. Now we need to do the filtration part here, because you can see sometimes we don't have the average wave period and the dominant wave speed, and those things we don't have. Because here we load the data. Now it's like data frame, because we loaded this data as a data frame. Now we can do whatever the thing that we previously learned. Now we are going to drop. Okay, drop NA. You know about this command. And access columns and say all. That means what is going to do? What will this command do? All the columns where all the row values are missing. This is the command that you asked previously. This is the command, the exact command that you asked for previously. So now it will omit whatever the column. If I view, let me type df.info. I can see how many columns I have: wind direction, wind speed, wind gust and wave, the dominant wave period, pressure, air temperature, water temperature, dew point, visibility, 3-hour pressure tendency. These are the values that I have in my specific data frame, this data set. Now I need to omit the columns where there's no any value. So if I execute this one and view df.info, you can see some columns are omitted, because previously I have 15 columns, but right now I only have 30. 2 columns are removed. If you closely focus, you can see that means those 2 columns doesn't have any value in there. So we don't need that column. So if I can print my data by using df8, it will show me the latest records. So now you can have a simple example, like you can load a different station. Just try to load a different station. You know how you can load this data for a different station. What's the command you need to use? First, you need to load this one, because you don't need to load this data like this library. You already loaded it as NDBC. Now I'm asking you to load the data set for a separate library. Just focus on anywhere. You can focus on any station. You can choose one station from here, and you can try to load that data. Just imagine if you are focusing on this station, because here also you have like recent data. You can use this station ID, and you can rename in here. Whenever you need to access a separate station, this is the place you have to change. So after that, you can access this data. Okay, now we need to access here. If I view the entire data set, let me see the length of my data set. Length, I can type then my data frame. From the length, I know I have 6,473 rows. Now I only need to focus on the recent 7 days. Just imagine I only need to focus on the recent 7 days. because from the head, you know, these are the, let me type df, so it will print all the values. So here, from here, I know the date period. So here I have from 2020 for March 23 to 2024, May 7th. I only need to select the data from May 1st to 7th. Now I need to filter this data set only for that specific time period. How I can filter that specific time period? From this data set, I'm going to extract only those values. So how I can extract those values? For that thing, I will load Panda. Now I'm going to load Panda. Import Pandas pd. And then I will type, okay, from df type, because in my data frame, if I view df.info, you know, I have a column named type, and it's already in date and time format. You can see I have a column named time, and it's already in date and time format. Now I need to filter data from this specific date range. So now I'm going to specify, okay, df type is greater than or equal pd timestamp.utc now. Now that this means is going to get the timestamp, the current timestamp from your system, and it will allocate. Like if I view this one, instead of typing this one, I can type like first I need to import Panda. We'll import the Panda, and then in the bottom line I can type Panda data frame timestamp UTC now. If I execute this one, you can see it's showing me the current UTC time by reading from my system. It's reading from my system and it's giving me the current UTC time zone. It will change. Like if I execute this one, after 1 minute or second, even you can see the milliseconds are here. It's changed. So you can see it's getting the current timestamp for my system. So whenever you need to use this one, you can use it. There's a function called timestamp in Panda data frame. So it's going to access that time and then submit. That means like minus pd.Timedelta. That means 7 days from current time minus 7 days. So it will go for that exact time period. So if I execute this one, you can see I can get that date. Let me copy this command and run in here. So if I do it like this, minus pd.Timedelta, then I can specify. If I hit shift tab, it's giving me like time delta represent a duration, the difference between 2 days or time. That means I need to specify, okay, from the beginning to how many time period I need. If I need 7 days ahead, then I have type days equal 7. So if I execute this one, you can see, okay, from this time to 7 days back, what's the date? Is automatically choosing that specific date. So now, what does this mean? If you understand this one, you know what does this mean. Df time mean from the data frame get the time and take the values where the time is greater than this time. So now it's going to get all those values and print only those rows. Now you can see if I print like length of my DF right now, you can see I only have 990 records. So now I reduce my data set to the days between this from this day to the current time, current day. So that's what I have done in here. Then I'm going to reset. Previously we discussed if I view the data frame, now the indexes are like scrambled. So I need to reset that index also. So I will reset the index. Now the indexes also reset. Now I have the data for the current previous 7 days. Now, okay, we are going for the plot. Now we can check, okay, how the temperature is varies between those previous 7 days. And the wind speed and the wave height or several things. Here we have several things like wind direction, wind speed, wind gust, wind height, and the dominant wave speed. We can check. We can plot. For the first thing, for the plotting, we need to import this one. I discuss about this one. We will discuss about this separately because the Matplotlib is the library that we are going to import for the plotting. So we need to import from Matplotlib, import PyPlot, not the entire Matplot library, only this section, the plotting section. From the Matplot library, import PyPlot as PLT. Whenever we type like PLT, okay, I'm referring this library. That means PyPlot inside Matplot. So if I run this one, now the Matplotlib is like Matplot library is imported into my dataset. So here if I go, you can see PLT is imported as a module. That means Matplotlib PyPlot has imported into my environment. So here you have to type this command like /matplotlib.inline space inline whenever you are going to plot chart inside your notebook. So if you need to, like if you don't want to view your plot, you only need to export it into a figure, you don't need this slide. But if you need to view the data in real time, like the plot in real time, you have to type this matplotlib inline. It's a by default command, you have to type this one. So now everything is set. Now we need to do the plotting. Okay, how we can go for the plotting? The first thing is in NCL we create the workspace. First we need to create the workspace. Okay, the size of the graph and those things. So here also we are setting by these two commands what we are doing. Let me copy this one. Instead of writing this entire cell, we can go line by line. Okay, from PLT we know. PLT mean referring this pipeline. There's an inbuilt command .rc. RC means you can specify, okay, for my plot, use this font. If you need to have your font in Times New Roman or something, you can specify. And your font size, your color or everything, you can specify in this command. Now I am only specifying, okay, font, the size is this much. And then my figure, my axis is AX, PLT, subplot, then my figure size. So if I execute, what will happen? I will end up with this plotting environment. The size is 10 and 6 units in width, height, and 10 units in width. And here, if you can play with this one. If I change this one, what will happen? The size. If I change this size, what will happen? If I change this one to 20, what will happen? Because here I mentioned like PLT-RC. You can copy this command. You can copy this command and search. In the Python, it will show you the Matplotlib pyplot-RC. So this is the command that we are going to use. So here you can see, if you use RC, you can even like in the plot, if you are going to plot lines, you can specify the line width or the line color. Also, you can specify like we will discuss like in the while you are plotting the data, you can also specify the line width and the line colors, or else you can specify them in the RC. RC means the common file, the common things for your entire graph. So here I only specify font. What will happen if I execute this one? Now the font size will be changed into 20 instead of the 12. If I execute this one, you can see the font size is bigger than previous. If I execute like 12 in here, now you can see the font size is changed. How you can change the graph size? So here we assign in the PLT slab plot. That means our plot and the figure size is 10 by 6. If we type like 10 by 10, what will happen? It will be like equal size square. Now you can see it's like a square. So this is where you can specify your graph. These are the commands to load plot. plotting environment. Now you need to load your data inside your plot. So the next command is loading the data inside your plot. So it depends with your specific plot, like a huge amount.
For resolution, there is another command.
Yeah.
API.
API.
The very high resolution, just change the API, not the size.
Yeah, the size is like with the units, like it can be even you exported this one like in this size, you need to specify. If you are exporting this graph, okay, how much is your like PPI, pixel per inch?
Challenges. You find that your map object file is
Yeah.
somewhere very small and that the space is empty. So when you go to before, it will end somewhere.
Because here we didn't load any kind of data. You can see the axis is from 0 to 1, and this side is also from 0 to 1. If we load the data, you can see this axis is going to be changed. If you're facing some issue like that, that means you you clip your data for a bigger region. When you plot in the data, you need to subscript into your specific region before go for the plot. Before go for the plot, you need to slab plot. Like we will discuss about this one in cartography. Like you are talking about a spatial map. If you are talking about a spatial map, we need to go for the cartography. We will discuss about this one in the cartography. Because you need to clip into a specific region. Just imagine you have a global database. Before you go for the plot, you need to focus on a specific area. Then you need to cut your data set according to this field. After that, you can load into the plot. Just imagine you cut the data set into this much region and you go for the plot. Even in the plot, it will show you the entire region. So you cannot do it in the plot. You can do it in the plot. That means you are zooming in into a section. Rather than doing that, the best thing is like you can clip your data first and then use that data for the plot. Then that means the issue is not with the plot, the issue is with your data. You need to like subset your data. So now we will load the data into this plot, the simple plot. So, okay, how we can load the data? We mentioned, okay, this one is our figure name is A. This is the name of our figure A. So, okay, for the AX, we are going to load AX plot. We use this command AX dot plot. Now we are going to plot our data. So this is also an inbuilt function. If I type shift tab, is not giving me any errors, like you can type. So here we have AX plot, then the arguments, then the scale, then the data and the other argument. So here we need to give, let me go for the example. So if I go for the example, you can see we have different lines and the stylings, and also the order, how we can give this the order of this data. So the data order should be in this format. First we need to give the data for our x-axis, then the data for our y-axis, then all the other arguments and the keywords. So okay, for this plot, just imagine I'm going to plot wind speed against the tide. So this axis will be my time and this axis will be my wind speed. So from the plot we know our first axis, the x-axis should be in the first. So from the DF I will select time. So that's my x. From DF select time. Then what will be my y value? Then from the data frame, we are accessing for these columns. I have this time, simple time, and also I'm going to plot against wind speed. So for the wind speed, I can either copy this one or I can type. So this is the column that I am going to plot. df dot, I can type wind dash speed. I can hit tab. So it will give me the values automatically. So now if I execute this one, it will show me the plot. But there are some custom arguments that you can go with this one. So we can give, like here you can see all the other arguments. In here what you can give. So if you need to have circle marks or something, you can type this command. You can explore this more. Like here you can see XY. Then if you are going to assign a line color for this one, what will be the color? You can type equal color equal then the color value. And then the marker. If you have a specific marker, like instead of a line, if you need to use markers for each and every individual dot, you can use markers. And in the bottom, they specify about all the markers that you can use. So here, if I go into the bottom, you can see they specify like what are the characters for the markers. If you use like within comma single dot, it will be a point marker. If you need to show it in a pixel marker type, you have to use this comma type. And if you need a circle, if you need to have a circle marker, you have to use this one. So we will discuss about in the Matplotlib session when we go for the discuss for the customizing your plots. Right now we are going to create a simple timeline. For that thing, we need to have a color in our data set. Okay, this is the data that I'm going to plot. Okay, then I have to specify, okay, I need this graph in this color. It will be like COLOR equal, then you have to give your color name. Then you have to specify your color name. I can type like orange. Instead of tab orange, I can type like orange. So it will know my for the color for this specific plot will be in orange. And then, okay, what's the label of this axis? Just imagine you are going to have a legend. Just imagine now you are going to show, if you have like multiple lines in your plot, you need to have a legend. In the legend, you will show the label for each and every individual line. For that thing, you need to specify, okay, if this is your first plot inside that actual figure, you need to specify your name of your data series. So that's why we use this label command. So I will type like label equal within bracket wind speed. So if I execute this command, what will happen? It will create a plot. So let me copy this one. So you can see it's giving me the error, and if I read the error, I can see orange is not defined, not a valid value over color. So if you make a mistake, you just go to the last line of the error code and you will see what's the issue. You don't need to read the entire line, just go for the last line and you can see the issue. So I can type orange. I think now it's okay. And I need to specify this one. It's not showing up. It's already drawn, but it's not showing up. Let me copy this command and paste it under here. So you can see now it's plotted, but we don't have the axes. Like for the y-axis, we don't have a label. For the x-axis also, we don't have label. We don't know what those values are mean. So for that thing, we have to use IAX. Then we have to type our axis labels. So this is our actual plot. Dot AX, then we have to specify set X. If you type this one, you will see X label, X limit. If you have a specific limit, if you need to focus on a specific limit, you can type it like that. So instead of viewing the entire data, you can specify a limit. Okay, just show me this limit of X. So it will show you only that specific limit. Here I am going to note, I am not going to limit the entire data set. So I will type X label. Then I can give the name of this axis. So I know X is type. And also for the y-axis, if I need to set the y-axis, what will be the command? AX, that means my plot name dot set y label. So I can type my y label is wind speed. Then I have already these labels. Let me copy these 2 lines and paste it there. So now you will see the labels are there. So if I paste it right underneath here, now what I have done here, I can add commands. I can add comments also. What does this mean? Setting the X and Y axis label. And here what I am doing, if I go for this one is to plot the data. And first thing here, what I have done, like creating the workstation, creating the plot environment and the plot size and those things. Then if I execute this one, now you can see I have those 2 axis label. If you need to add a title for this graph, what will be the command? Your figure name, then set title. So if you need to add a title, this will be the command AX dot set title. So this is to set the title for that graph. So if I execute this one, you will see now I have a title for this graph. Now if you need to add a grid, what will be the command? There's an inbuilt command, grid true. Like by default, the grid is disabled. If you need to enable the grid, you need to type your plot name dot grid true. So I can paste it in here. So now I can view my data with the grid. Okay, now one thing is missing, my legend. How I can add the legend? When you add in the legend, the command is AX legend. But in here, you can specify the locations. You have to specify, okay, where should my legend go in the graph? So if I view the doctrine of this one, it's showing me legend, then I have these things. If I go into the bottom section, it will show me the commands I can use, the location. If you type best, it will automatically choose the location for you. If you type upper right, it will go for the upper right. So these are the things that you can use. Either you can use location code or you can type the entire string. For this thing, I am going to locate my legend inside the upper left corner. So if I execute this one, you can see my final plot. So here is mentioned like wind speed. Where does this wind speed comes? Because here, when I do the plotting, I rename this one, my series as wind speed. That's why I have this one. Okay, now we have that one. Okay, now we have an issue in here. If you closely pay your attention into the time series, you can see the time is like congested in here. Instead of this one, what if we displayed only the months and the days? Because we know these are the recent data. Instead of showing the year, we can show only the days and months. How we can customize these axes? because we have only 7 days. 1, 2, 3, 4, 5, 6, 7. Because from this section we filtered our data for the recent 7 days. Now we are going to plot that thing, and we already plot, but these axes are not formatted. We didn't format this one accordingly, so we can format this one, like beautifying the graph. Now how we can do that thing? So for that thing we can use this date formatter. It's also a by default library, comes with Matplotlib. So there's an inbuilt library called Matplotlib dates, and import date formatter and date locator. So you need to import these two different libraries for the formatting. Then you have to specify, okay, from x-axis, set major locator as the day locator. So let me copy this command and remove this line. So you will see the difference. So now you can see, you cannot see, actually we didn't format. Now it's assigned in right position. You can see here we have the correct days, the correct locations. Now we need to format. Now it know x-axis has the time and is located in the x-axis. This every value is not a integer value or anything, is type. Now we need to do the formatting. For the formatting, we can type x-axis set major formatter, then the date formatter. We have to type the format of the date. So for the month, you can type %m, and the days you can type %d. If you type it like this, it will show you only the month and the day. If I execute this one, now you can see it only appearing your month. Then here also we have a separator. You can, if you focus clearly, you can see you have a small separator in between here, like this slash mark. That's why you have something like this. So that's how you can format the days, like dates in your X or Y axis. So, okay, how we can add another plot into this one? Just imagine here we are showing the wind speed. If I need to display the wind gust also, because in my data frame, if I view the my data frame, in my data frame I have wind speed and wind gust also, because wind gust means the maximum wind speed we had during that specific time, and the wind speed mean the mean wind speed during a 1 minute or 2 minute interval. So we can plot it in the same graph. How we can add the new series into the same plot? It will be same. How we can add? We know AX, then plot. Our original figure is AX. We are going to plot another series. This time it will be DF time versus DF wind gust. And then the color. Here I'm going to assign the color olive. If I need to assign green color or something, I can type like green. Assign green, so it will be much more simple. And the line. So previously I discussed about this one, like line styling. Here also we have like line styling also. If we type like line style, if you need to have a dash line, you can type line style equal dash. So just view the doctrine. Every time just view the doctrine. If you view the doctrine, you can find everything related to this plot. This one is actually a scatter plot. That's why we every time we type like AX plot. Sometimes you will see something else instead of plot, but we are using that thing. Shift tab. It's actually shift tab. 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 Shift and tab. Then I am labeling that axis as wind gust. And also I am showing this one in the legend. Now if I execute this one, you can see both lines are appearing in the same graph. So the green color dash line will be the wind gust, and the wind speed is represented by the yellow color line.
Expect that when we publish that, because we specify the DF dot time and then DF dot that. So we see the repetition of time on the x-axis.
No, because we are using the same float. If we are using the same float, it's going to share the same axis.
So there's a no need now to indicate the time.
No need. You don't need to specify it again. Like if you type like AX1, here we are accessing the same time.
What is the function now? So now the different function.
DF time mean I am accessing this data frame. From this data frame, this float function is going like this. If you use like this one will be your float name. This one is your float name, then float, then within bracket. Then you have to assign the values of x. Then you have, after the comma, you need to assign the values of y. Then whatever the formatting that you are going to do for your series. It's going like this. If you need to have another float, you can get your float name. That in here we use AX. If you type something else, you have to use that name. Then float. Then you have to assign X and Y, and then you have to label this series also. So if you continue it like this, you can have multiple values in the same chart. But here you need to focus, like you have, this one is actually a scatter flow. That's why you cannot like change, if you try to change this axis, it will give you error. Okay, now you can try to create this one. Create your own figure. You can, instead of typing AX, you can use my AX, and you also can use my figure instead of typing figure. Okay. This is almost 80.
Why change this? Orientation.
Yeah.
Stick groups rotation. Down the x-axis.
Yeah.
That one is
Yeah. Yeah, you can do that thing. If you need to orient that thing, here is the location that you need to change. Because here DF time mean your x-axis, and then DF wind gust mean your y-axis. You can change those two axes. Then you can change the x and y. Yes, let me change this one.
I will show you that.
Yeah, you need to change this one. Just imagine.
I will show this. Yeah. Yeah.
So here.
HD label.
So if I execute this one, now you can see. See, time and the day. You can change it. Okay, for the attendance, you can mark these QRs. So you can mark this, mark the attendance to today's class.
Yeah, no, let me see. I just deleted this one. There is no HD. But for my
H-stick label. There's two layers. H label is only the label of this entity. Stick label is the URL. And then this digital is digit 101. These are the stick label.
That's why I'm saying, like, if you know your data set exactly, you can go, like, easily go for the plot. The only thing is, like, you need to know about your data set. If you know about your data set, the plotting is simple thing. Then the hardest part in the plotting is like customizing your plot.
I would like to find it. First, changing minus to positive. Only one. Maybe problem about that time series. In time series, I want to get each date and time of first changing minus to positive.
You mean the difference?
No. These are the my time series. This is time and this is my data. And here there is the standardized. These are the positive. Then 60%, it's maybe one. Then you take the negative. And then negative. Then positive. But I would like to accept this one. Only. I want to accept this one.
You're going to filter the data with the minus values or
Like my example is I had that SCDF already calculated standardized. First, I would like to report that this point. First time on negative. Then I have to most of my satellite. My definition is first.
I think then you have to do something like looping. You have to go for looping. You encountered the first negative value for this, you have another access for this one, right? Then you have to focus, okay, this value is negative, then focus like station. Just here you have station. For the station, if you get the first negative value for the specific station, just I got that value with this one. Like data frame data set. You have to do it like that. When you identify something, store it in the different thing. You have to create. Yeah. You have to create. We have to take whether they are like a code method or something.
I have to
Yeah.
take this one.
Yeah. You have to go through each and every individual row and then just select the first value. With the first time step. If you are focusing on the time step also.
I change like SCDF for the reason why.
Yeah, if you change the XDF file, the Excel file, how sometimes even Excel cannot open the file.
Now I currently make a zero value, zero line. In necessity a zero line is easy, but zero line only zero line.
Guys, you join online, do you have questions? How is everything? Now you need to create this one.
Yeah, I can do it. Maybe if you because Excel data. Mostly I mostly I do this, but I use it.
Okay, because even the net CDF, you need to read the net CDF,
Yeah, sure.
and then you will import it into a data frame.
Yeah, sure.
From there also you can see like DF is there.
Yeah, it's there.
Because you cannot directly work with the net CDF. First you need to read the net CDF and then you need to export the table into the data. And then you can.
The only command that I did. How if it just recorded the year, month, and then you need to remain with the date and the month.
You have to use this one, these two lines. If you are going to format the axis, just imagine if your date's in the y-axis, here you need to change this one. Y-axis, set the major, then the date locator.
You feel like this one. You use the word May instead of 0501, then it's written May.
Yeah.
Where
So here instead of B, you can type, you can use this date formatter. You can find the date formatter because we are using the Matplotlib date formatter. So if I type like go here and type it, so
based on the data, should be the last
anak-anak semua datang untuk fungsi cara penampilan semua
I got it. That's why I want to
so format is like this. So if you show year and with the month, then you have to use these two characters instead of days.
as far as
Then it will be like if you use percentage capital Y, it represents the years. If you use percentage B, it represents the month. If you use like percentage D, it represents the days. So here in the code we use only percentage B and then percentage D. That's why it's everything like this.
But the one that you showed it was 0501. It's not May.
Oh, the previous one.
Yeah, this one. You see? How to convert now this one into May? 0501 now.
So here you can go into this command. Here we type simple percentage M. If you type percentage M, it's going to get the month, actual month. You can see like here the difference is like B. If you type B, it's appearing like this. If you type M and execute this one, now you have this. I will try to find like chart for this one, like with the command. So otherwise I can generate. What does this each and every individual like? The formatting is like you have to use the percentage, then there will be the letter for the format. If you use M, it's including the months 0, 1, 2, 3. If you use percentage D, not D, G, this one means yes, M. And if you use percentage B, it will be from 1 to 21. And if you use percentage Y, it's going to only get the year number. Like first 40. Even for the years, you can like subtract only for the last two.
Yeah, the simple command that you when you For example, I want to know about all about this one. So read that one. And then you control picture and post the document.
Yes. For the percentage mark, there's no like percentage mark is there for this one. You can try to shift tab. Yeah, they show it. But the problem is they are not showing. Even in the date format, the format that you need to use, like format.
Same idea. Same idea.
Like go here.
Yeah. The finding is our nobody. So I will open the after 10.
Not showing. They should show something like this. If we find a graph like there are some several graphs like you can use these formats like you can know from here what will happen if you something like
Dash.
then
Percentage means listening.
That's the doctrine.
shift tab. If you need to view anything,
The doctrine for this, you write, for example, for command for data. This one. What do you use to read the data? It's the Buoy. The short command.
you mean here? Just imagine if I need to set X label, you need to put your cursor within these two brackets.
Yeah. For example, you need to know about
So this would make it
Yeah.
all the commands you get.